Hello, people. We'll be starting the session in 5 minutes and waiting for people to join in more. So please stay tuned. Hello, guys, and welcome to A.I.M and welcome to Pi Meetup, Gujarat, with Denima. Today we have a guest, Denima. He's the founder and CEO of Sydney Data Science, and he'll be sharing his experiences and insights into the importance of learning the basics behind data science, and is it very important to just run behind using pre-trained models? Also, I would like to thank our community partner Merge Intern for being such cooperative and sharing this event with everyone. So before starting this event, we have a video by DeepLearning.AI by N2NG.
Hello, Deep Learners. I'm Andrew, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so we can see where it all happens. Oh, hi, Andrew. Do you want to tell our friends at Mind AI what you do at DeepLearning? Sure. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having. Today, I'm putting together the next issue of Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed. What's been the most surprising thing you've run into working on the Batch? How much is going on this? There's never you know, you might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right now as I put this thing together. All right, I know you're really busy, so I should get back to you. So that's the VPN who helped me create the deep learning specialization. He's working on an exciting new project. People at Pine AI
AI what you're working on?
That's true. I'm leading a project with Gujarat. People get offers with AI and navigate their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs with AI.
That's really cool. And what's the most exciting part of your day?
The AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what the different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really impressive work. It's nice chatting. And now let's go chat to Hotel, who is on the product team. Do you want to say something to our friends at AI that didn't know what you're working on?
I would love to. I lead the product team, deep learning.
And now we have Danny with us. I'm really very sorry. Maybe the video was lagging or something. I'm so sorry for it. But yeah, and welcome Danny to the meetup today. And I hope you'll have a very great session with us, answering all the questions from our viewers.
Hi, Manpreet. It's so great to be here. Sorry about the video earlier. Maybe it's me because I joined on with some high quality, some picture or something, maybe hogging up your internet. But yeah, thanks so much for inviting me onto the show, and I'm really happy to be here. I hope I can help out as many of our viewers as possible and try and answer as many questions and provide value tonight.
Yeah. So will you like to share about something about your work currently and your data science, like what you are into currently and something
Sure
about
thing.
you for our viewers?
Of course. Yep. So my name is Danny Ma, and I'm the founder and CEO of Sydney Data Science. For the past 7 years or so, I've been working in the data analytics and the data science and machine learning space within Sydney, Australia. So I've worked in a few companies within Australia, which are quite famous for their data, for both the size of their data as well as the competency within the companies. So I've worked for Quantium, which is Australia's largest data consulting firm. That's when I started, where I started my career, and I worked in campaign analytics and data analytics, working with data coming from Woolworths, which is the largest retailer in Australia also. So I spent a lot of time working in the retail industry, and then I moved over to banking, where I worked with the Commonwealth Bank, which is Australia's largest bank, and they also have a lot of rich customer data. And I worked specifically within digital within my career with the bank. So I was using a lot of the digital experience and all the different customer behavior data within that to try and make predictions and use machine learning to solve different problems. And then after that, I moved to work within Woolworths as a contractor through my company. And I worked there to essentially help them design their machine learning pipelines and build up some of their data assets from a data engineering function. And most of that stuff was done within the cloud. So it was a new experience for me. And probably for the last 6 months or so, I've been very focused on trying to leverage my own skills to try and help out as many people from the community as possible. So I've really doubled down on trying to make myself more present and available to help people through LinkedIn, through the different communities that I'm running at the moment, including the Data with Danny Slack community. I think a few of you guys are on here tonight as well. So thank you so much for joining us. I really hope that you guys can come up with some great questions, and I'm here to answer them for you. But yeah, I hope that helps explain a little bit more of my background and where I've had my experience. Yeah, I hope that helps.
So how did you get interested into the field of data science? Like, what was something that made you interested into the field of data science?
I remember when I was working at Quantium within the data analytics and the campaign analytics, I felt that yes, I was doing a lot of very cool work and it was very interesting. I was solving quite a few challenging problems with the data there, but I always thought, okay, this is cool, but what else can I do with the data? I've heard that I can use the data to try and predict different things. I want to do something which is a bit more impactful with the data. And when I started asking some of my peers, they told me, oh, you should check out this thing called Kaggle, and you should start doing some data science. And that's where I started, essentially. I started looking at a few different problems within Kaggle. And I remember one of the problems that I started working on, I think it was like the airport, trying to predict the delays or trying to predict when the planes were going to go into different airports and try and predict the amount of duration that it was going to be delayed, if it was going to be delayed. And I just thought to myself, wow, that's crazy. Like if you had someone try and do all that data themselves in SQL or Excel or anything, you just wouldn't be able to do it. So that was like my first initial problem that I saw within the machine learning space. And I thought to myself, oh, that's really cool. And when going through university, I always I like those larger abstract problems where you're not necessarily given, like, there's no real correct answer. There's just a lot of stuff going on and you have to try and make it a bit clearer based off whatever your insights are or however you're going to analyze the data. So I thought that was pretty interesting. I think that was back in, must have been like 2013, 2014, around that time. So that was my first exposure to some of the machine learning problems. And from there, I just kept digging and learning more things. So yeah, I found it was a really great experience for me.
That's really great to know. So, what do you think, how important is for a person to have a mentor while being in this field, or how important does this community play a role while shaping yourself in any field? I guess it's very important to be a part of some community or another. So, how important do you feel a mentor in a community plays a role in shaping yourself?
I'll talk about the mentor first. So I know some of you guys have probably known me from my posts on LinkedIn about personalized mentorship and finding a mentor and how important a mentor is for your data science career. I think it's not only a mentor is important for our careers within the data space, but I think mentors are important just in life in general. To be able to find people who have done the sort of things that you've already done or accomplished really amazing things, they usually are the best people to learn from. So I found when I was going through my career in data science, I learned a lot of stuff myself. So I was reading up, I learned how to use Python myself through Code Academy, for example. I was waking up really early in the morning and trying to learn that on the side whilst I was working in data analytics. And then I started learning some of the packages and I kept going. But the point where I started to apply my skills in a more correct way was when I first started working with data scientists within the bank. So within the bank, my first project was to try and build up a model to try and predict who was going to take out a certain product, a banking product, within a set number of times. So you're trying to predict the future, essentially. So on that project, that was the first one where I actually got buddied up with a data scientist, a senior data scientist. And I would say that he's probably one of the best data scientists in Australia at the moment. He's amazing. So essentially when I started working with him, he showed me everything, essentially. So it was, and I thought that experience of working with an expert and having them guide you on, oh, here's how you set up everything properly. Here's how we interact with the database. Here's the sort of commands that we run. Oh, you might want to store these sorts of shortcuts within your bash profile. Here's some of the tools that we use. I think having that sort of experience and hands-on approach from a mentor was very, very valuable, especially within the data space. I found that within data science, there's just so the breadth of things that we're supposed to know is just so huge. Like part of the challenge is just trying to find out just exactly what tools should you use, what IDE do you use, how do you set up your Git, for example. All of these problems, pretty much when I was working, or before I worked with my mentor, I kind of had a vague idea of what to do. Like I fumbled around and figured out a way how to do it myself. But I think I would have saved a lot more time if I actually had someone to show me right at the beginning. So in a way, I think what I'm trying to do on LinkedIn and what I'm trying to do on the Slack is just try to provide that sort of personalized mentorship experience to help people who are just starting off, or to help people just validate that whatever they're working on is going to be used in the industry. But I think that kind of ties in well with the value of being part of a community. So 2020 has been a very difficult year, but we've also been stuck at home a lot, and it's very difficult to interact with people in our physical communities. So traditionally, you might have seen like there's meetups around where in your local city you might have groups of data people who just meet together, and you can talk and present and learn through those different functions. But now that we're in a pretty much a digital world where everything is connected, so now we can kind of interact with people on LinkedIn. We can send lots of messages and try and ask people for advice. And to take it to the next level, I think having these communities on LinkedIn, on Slack, on Discord, wherever the communities are, I think it's only a net gain for the whole wider data community in general. Like I'm sure people must have heard like, oh, there's 500 million shortage of data workers, artificial intelligence workers, or machine learning workers in the entire industry. What are people doing to try and bridge that gap? Like, are we going to do it through education? Are we going to do it through more people joining LinkedIn? How are we going to do it? And I think having these sorts of communities, which are kind of homegrown in a way, where people in the field who have the experience are trying to build up a community of like-minded people to kind of bring everyone forward, I think it's very admirable. And this is part of the reason why I wanted to do it, because I so admired some of the people who were building those communities. I thought to myself, oh, I've got some good skills, and I think I can share some of my experiences with other people, and hopefully it will help them. So why not try it? And then I put myself out there and just see how it goes. And I think the results have been pretty good so far, but it can only improve over time, I think.
Thanks. And how do you see like when people shower so much love on you, and like they look up to you as an inspiration and someone they can trust upon something? Because when you're choosing a mentor, it's very important that they show you the correct path and they don't mislead you. How do you feel like when they respect you and you help the community so much? And also, how important is to choose the correct mentor? How would a beginner know that this person is the correct guide, or this person whom I'm looking up to is the person I should look up to? Because in these times, people to be framed as a cool person and a data scientist, it's generally getting very tough to identify someone whom you can actually trust and be guided truthfully by. So, like, can you answer my both the questions?
Yeah. Definitely, I think it's very, for me personally, when I have all these aspiring data scientists send me messages and say thanks, and like, thank you so much for the free courses, or different things like that, I feel really great about it. But I also feel almost like a very big sense of responsibility. I think as a mentor to people, you do take on some sort of responsibility. Like you're essentially saying that you're going to help other people in their career, and it's not something that we should be taking on very lightly. I think this is part of the reason why we don't see too many people in the industry actually go out there and actively look for mentors, look for mentees or people to actually help, because it takes a long time. I think there's a lot of energy and time investment from any of the mentors to actually help people. And I really think for me, it's part of why I'm here. Like I feel that I was meant to help a lot of people. I'm just trying to make my vision come true. But I think on the flip side to that, there is, so the darker side of this mentorship and the stuff about branding yourself on LinkedIn and trying to get your name out there, for example, is that people are starting to realize that to get great jobs or to get promotions and improve your career, there is some aspect of being present on social media, and there's always going to be that like double-edged sword in a way, where a lot of people are going out there and saying, okay, I need to make it seem like I'm very good at the data science and make myself seem popular just so I can get my promotion or be LinkedIn famous or be Instagram famous or whatever it is. And the best way to identify those people and try and stay away from them is you really need to see how they're interacting with people. And it doesn't matter how big or small the interactions are. I think when you read through a way that people comment on LinkedIn, or the tone of their voice when they're writing their posts as well, I think it's very clear that there's the main key to the people who are very, very popular and very, very they have a big army of fans behind them, is because they're so positive and authentic. And being authentic is probably the most important thing. I think it's super important to, yes, the personal branding, like you have to be yourself, of course. But when you think of helping other people, I think that's very powerful as well. Coming from a social media world, it's very easy to write posts that highlight how good you are, but you're not helping anyone. And I fell into that trap before when I was like, say, 2 years ago, when I was posting on LinkedIn. I would post like, oh, here are the top 10 things that you need to know to be a great data scientist. And I was just, it wasn't about telling people, here are the top 10 things that you need to learn. It was more about, oh, here are the 10 things that I know, and I'm so cool, I'm great, you should follow me. And I know that a lot of people out there, they try and do that because they've seen other people do it, and the other people are very successful. They build up a great LinkedIn following or an Instagram following or whatever it is. But I think those sorts of personal brands, they don't last. Like sooner or later, people would just be like, oh, Danny, why you're just posting stuff about how good you are? What value are you bringing to the community? What sort of things are you helping people with? Like, are you even doing anything with your audience? So it's tricky in this sense. But I think on our LinkedIn data community is great. Like, there's a lot of really powerful people who are really out there to help people. And I think like some people have their entire businesses around building courses to help improve people's skills. And I think that's very admirable. Coming from an industry background, like most of the time when you think of data scientists, they just want to work on business problems because that's where they can bring a lot of tangible value to a business. I think helping other people work through and learn their own skills, it's a much more blurry space, and it's much harder to actually find whether you're delivering tangible value. So for example, I chatted with Lillian Pearson, for example, and the story of how I met her and talked with her on LinkedIn was actually when I think I was reading one of her posts, and then I just commented, Lillian, thank you so much for writing your book. I read one of her books in like 2015 or 2016. It was called Data Science for Dummies. And I was telling her, oh, that book really helped me. Thank you so much. And then she responded back saying, oh, it's so amazing to hear someone actually comment about the book, because as an author, I think she would just write books and then you wouldn't hear back from people directly. So it's very difficult to know as a mentor whether you're actually, like, you don't get the feedback to say, oh, am I actually helping people? How much value am I bringing to people? I don't know, because I'm just writing my book and publishing it, and then they tell me how many sales I make. I don't know if it's actually helping people. So I think a lot of the time when you're looking for a mentor, you try and judge it by their personality, whether you'll get along with them, whether they're, of course, some of these people on LinkedIn, they're going to be super busy. Like I receive tons of messages and I feel really bad when I can't respond to all of them because I just don't have time sometimes. And as much as I'd love to respond to everything, there has to be a fine line between how much time you spend responding to messages, for example, and how much time you spend delivering value and doing things which are valuable for the larger community. So I think when you reach out to people and you're asking them to be mentors on, say, on LinkedIn, for example, just be very mindful of your language when you're talking to them. Of course, it's difficult if English isn't your first language, but you just have to try your best. And I think the most important thing is just reach out and don't seem to be like you need that, like, how do I say this? It's like, of course, it's implied that you need them to help you. But I think in another way, a lot of people always say, when you have a mentor-mentee relationship, you need to get, that the mentor has to get some value from you, which I strongly disagree with. More often than not, the best mentors are the types of people who freely give away their time and their energy and their information, and they don't ever expect anything in return. Those are the best mentors. Do you really want a mentor who says, I'm only going to mentor I'm only going to mentor you if you help me write a blog post or help me do something, or I need some value out of you. Otherwise, there's no point in me mentoring you. What's the point of having a mentor like that, right? So I think for all the viewers and the audience, if you're looking for a mentor, try and find people who are of that mindset, who they're just there to help. They try their best. They put in as much time and effort as they can, but just be understanding, because often these people who are actually out there helping others, they'll be in demand, and there's a lot of people who need the help. So I think just be very mindful when you're messaging them. Sometimes, say for example, people send me a message, I actually don't see it. So if you send me multiple messages, I have a better chance of seeing it. But then if you send me multiple messages, I might think that you're spamming me. So there's a fine line between what happens. So hopefully that helps.
If you see people on LinkedIn writing about data science internships, and they would write a post like, add me to your Telegram group, I'll add you to the Telegram group. And then they are building a community in a way, like they're sharing some links, collecting all links of
Yes.
internships and state telling. So what is your thoughts or opinion on this? Do you find it funny, or like something, like, is it helping the community, or what is your opinion on it?
So I think it's very admirable that they're out there actively building up some resources to try and send people. I just think the execution of how they're doing it is not the best. So say, for example, if I wanted to, say, send a PDF out to everyone, I would not go on LinkedIn and write a post to say, I have a free set of machine learning resources, comment with your email and I'll send it to you. Because one, we shouldn't really be sharing too much personal information on LinkedIn or anywhere. Emails, like we look through our emails every day. Do you really want to be sending it's essentially like your address, like it's your digital address where you get all of your mail. Do you really want to be sharing it with so many people? That's one thing. Second would be, for the person who actually posts it, it's very, 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 very difficult to actually respond to every single message and also get the data out of it to actually get the email. Trust me, because I know exactly how bad it can be. Just to try and identify who has responded to. I remember before, when I was doing my personalized mentorship, the first post that got me a larger following was I said, is anyone interested in personalized mentorship? Please reply to this. Please say, I'm interested in the comments and I'll try and get back to you. I was expecting, I don't know, maybe 20 people or 30 people, max 50 people. And then overnight, 1,000 something people responded to the thing. I couldn't actually physically figure out who commented on the thing, because there were too many things. I just didn't have time. So I think for anyone for anyone watching, if you see those posts where it's saying, leave your email and I'm going to send you something, don't do it. Just avoid it. I think regardless of how good the information is or whatever it is, like I just don't think it's worth your email, for one. And also, like, yeah, I just don't, personally, I don't like those sorts of posts. There's many other ways that you can execute it. Maybe I should reach out to some of those people who are doing those posts and let them know, like, oh, use my referral link for this sort of email, for this email tool. You can get emails much easier that way, and you won't have people exposing their emails. But I don't know. But yeah, I am not a fan of those emails. I think LinkedIn should ban them. Like, it's not what the platform is for, I don't think.
With this consistently growing field of AI, you see different things evolving in AI. Like earlier, people never knew what AI is exactly, and now every other thing, AI applications are being built. So, how important is to be consistent, performing in this field, learning, growing, contribution? How important is to stay in this competition? Because now, with evolving time, when I see myself now, what I'm learning now, my junior or sophomore year student in colleges has done lot of more things that what I am actually going and doing now. So how important do you think it's very to be stay consistent practicing in this field?
Very, very good question. So there's a saying within Australia anyway, within the technical industries, is as you get more and more senior throughout your career working in a technical field, you can't compete with younger people in the technical arena. So it's, say for example, for me, like when I see all these awesome computer science graduates coming out, I think to myself, man, they know so much more than I knew when I was starting. They know about as much as I do now. Can you imagine like how strong they will be in this field after 10 years of practice, for example? So I think over time you realize, okay, there are almost two paths. You either stay within the technical profession and you continue upskilling and learning new things and increasing the breadth of knowledge that you know. So say, for example, within data science, you might need to know multiple different technologies. You might need to know, let's say, Python, R, SQL, cloud computing, GitHub, all these other things, data machine learning, data pipelines, Kubernetes, Docker, all these different tools to really stay ahead of the curve. But you almost need to make a decision whether you want to do that. So there's almost two paths. So one would be you continue upskilling and learning the technology. And I highly recommend this if you love learning stuff. So for example, for me, I really love learning all that sort of stuff. And further to that, I love teaching that sort of stuff because I always felt that when there's a saying where it's like, oh, you can learn something, but you learn it much more if you have to teach it to someone else. I fully believe in it. So yeah. I think it's, yeah, like you find the people who teach others, they must understand it, not just for themselves, but they need to understand it and reproduce it in a way that can actually help other people learn the same skill. So I think it's a great challenge for anyone who's learning all of these technology to actually keep really solid notes and learn something with, like, there's another saying, I'm full of sayings today. There's another saying, like, if you start with the end in mind. So if you start learning certain skills, of course you want to apply those skills to certain business problems and be very good at learning them and be very proficient, but you should have a meta goal of, okay, I want to learn this so well that I understand it so well that I can teach someone else who has no idea about it, because I wish someone taught me how to use it, but I had to figure all this out myself. I think having that sort of mindset is very, very powerful within the technology space. It doesn't have to be data. It could be software engineering, machine learning, front-end development. It doesn't matter. I think anywhere where we always have to be learning new skills, it's very, very important to actually do that. Because I think so let's say we have to apply for new jobs, for example. How do you demonstrate that you really understand a certain tool or language? Like you can write it down, right? So you can say, oh, I've got 5 years of experience writing R code, which is, it might work for some people. But instead, if you have a blog that has 100 different articles where you're showing 100 different things in how to build charts in R, for example, is that not stronger? Is that more like it's almost like you're talking through your actions and your artifacts and the way that you're actually helping people. So I think it's part of the movement which I want to make happen. And I think that's where a lot of people should start focusing their time on. So yes, you can learn a lot of things, but you have to think about, okay, one, why am I learning it? Two, okay, say I learn it, how do I demonstrate to others that I've learned it? And three, okay, I want to learn it and I want to be very good at it and I want to demonstrate how well I know it. Maybe I should teach someone how to use it and then document the process of my learning. So yeah, I think for everyone who's watching this, you should try and any new thing that you learn, always try to learn it as though you were going to have to teach someone later, because I think that's how you really learn something very deeply.
Okay, so the next question that I have is, what are the misconceptions you believe as a beginner people have about data science?
Okay, I could probably talk for days about this, but I think I'll start with the largest misconceptions. Whoa, which topic do you want me to start with? Because I think I could go off in 100 different directions for this one.
No, like suppose I'm a beginner, so I have this people might have this misconception is, if I do a very cool project and 1 and 2, then I'm a cool data scientist. Don't you think this is one of the misconceptions people are having? I implement some transformer paper and I know data science, but do they deeply know the what do you say, the behind things happening in a model or something? So about that misconceptions, like people believe, a general public believe that it's about predictive algorithms or just self-driving cars, but there's a lot of things happening in data science, but a general public doesn't realize about it. So some types of these misconceptions, what do you think that if a beginner is entering into the field and he's having such misconceptions, so what is your take on it?
Okay, I think the first point that you raised was really, really interesting. So the one where you're trying to implement some sort of algorithm or implement some machine learning research that you've read, and you implement, say, in Python, and then you say, oh, I know machine learning because I implemented a recent research paper. That is a very, very common misconception. I think it's very good if you can do that. So there is part of the data science and the machine learning industry where you need to be able to implement research papers. There's definitely a space for that. But to be frank, junior data scientists do not do that. Like you'll never be in a role, or maybe not never, but you'll hardly ever find a junior data scientist or a junior machine learning engineer who has to implement papers from scratch and implement them in some sort of problem. It's a very useful skill to have, of course, and it's actually not easy to implement some papers. So it's a very good skill to have, but it's not fit for purpose. So if you're trying to get into a junior data science role, you should instead be thinking, okay, what sort of tasks am I supposed to be doing when I enter the industry? What sort of skill sets do I need to be comfortable with so I can start adding value when I'm working? More often than not, the best skills to be very good at is documentation, being able to analyze data, being able to read in data, being able to visualize data because you have no idea what's inside because this is the first time you've ever seen the data set and you're being asked all these different questions about it. I think one of the common misconceptions about data science is that everything is automated. There's, I think, like, there are some components which are automated. Like, sure, the machine learning pipelines and some of the data processing pipelines can be automated, but they don't ever start with automation first. You always go through, like, the whole point of doing the science component is you run experiments, not just experiments in terms of doing like A/B testing and different things with the statistical side of science, but more around, we do science in terms of, okay, let's try, I have a hunch that the data says this about certain customers. Let's run with that and see if that's the case. So the science component of data science is not about predictive modeling or machine learning or anything like that. The science component is actually having a hypothesis of what you think and an assumption of the data, of the scenario, of the state of something. And then you work methodically with the data to either prove or disprove your hypothesis. I think that's the thing that a lot of people miss when they think of data science, because they think, oh, it's data science is visualization. Data science is using SQL. Data science is deep learning. Like, all of these things are part of data science, I would say. But the core of data science is actually coming up with ideas and using the data to validate those ideas. And the closer we get to that, I think that's where we can stop having those debates about, do you use R or Python? Do we need to use SQL? Do we use Excel? All of these different things, like it in a way they matter, but they also don't matter at all. Like, I think if we stick to the whole concept of, are we doing data science, that makes things much clearer. Or it makes things much clearer, but also makes them much messier in terms of tooling. So I understand why some of those debates are there, but yeah, but I think that's a very big misconception, that data science is just analyzing data. There's the purpose behind analyzing data is to validate those ideas.
We have question by Vipul. The pandemic has changed a lot of things for us. How credible will now past data is? For example, in space of marketing, how does this affect the data science and how to deal it with?
Yep, this is a very, very good question. So for the big brained people, yes, this will make a huge difference. There's a word for this. We usually call it non-stationary within the statistical term. So data from the current period or the recent period does not match data of the past. So you cannot assume that they're of the same distribution. So a lot of the common models that you build, they will tend to not fit out of time samples very well. Say, for example, or even if you started building a model and you did a random cross-validation, whatever it is, across the whole time period, say we have the last 3 years of data, the fact that the last 6 months or so has been so different, when you start randomizing across that whole selection, you'll have some issues. There'll be big issues with your model. And this is like, it's not something where you can't spot it in the metrics. So the thing about these sorts of changes is, let's say we did build a model over the last 3 years and the model scores are good. Let's say the AUC or the RMSE is very good, but it might still not work, because it really depends on how you craft up the data sets to actually build the model. So you could build your entire machine learning pipeline and everything looks great, but if you haven't thought about logically where the data is coming from, is there going to be a change in the data? Will the algorithms actually learn the right thing? Then you're destined to fail before you even write a line of code. I think that's super important, and not many people think about the data science in this sense. They always think, oh, all I need to do is get the data. I get the data for the last 3 years, XGBoost or whatever, neural network. I put it in, I use Keras or something. I put the final layer and everything will work because my RMSE is 0.3 or whatever it is. It's not the case. A lot of times when we think of the machine learning and doing predictions, I think this is why, so normally when we thought of the predictive modeling and the statistical modeling, a lot of the original applications were within engineering, within insurance, within finance. A lot of those areas, their models might be older and the methods that they use are very simple. but those models are statistically correct. And I think having a really strong understanding of statistics and distributions and literally statistics is about like what happens in nature in a way. Like there's all these different distributions and things that happen. And as data scientists, we need to have a better understanding and intuition of these things because we're trying to predict what's going to happen. And we only have so much data to deal with. And you have to have a great intuition of, is this data going to be valid for this prediction or not? And I think that comes with working on a wide range of projects, working in different domains, working with different types of data before you get a better understanding of this. But yeah, it's a super big brain area. And Vipul, I think, is on the spot with this question for this one. It's perfect.
Yeah, so the next question is by Ayush. He is asking, you said that you began your journey with Kaggle. After years of experience, what do you think about it? And I guess I even asked you the same question, like with advancements in Kaggle, being a Kaggle grandmaster, master is something that brings you job or something? Or is it something we can build our own projects on GitHub and show? Like how important that title is playing nowadays? In this data science community.
So I'll tell you a funny story. So when I first started doing the Kaggle, I thought that I had to win a Kaggle competition before someone would give me a data science job. That was my thinking, like back in 2015. And like I started working on a Kaggle competition, and I built the model, I'd submit my score, and it was like crap. It was a terrible score. Like I think I got in the average somewhere, like maybe bottom average, bottom third or whatever it was. I thought to myself, damn, I suck. How am I going to win this? And then I read some of the other examples, and they were like, their scores were amazing. I just couldn't figure it out. And I think when you work in that environment of like everything is a competition, you need to beat someone, you need to be first before anything happens. Or I think that's not a good mindset to be in. Like, of course, people are going to say like, oh, we need more competition. You need to be competitive so you can be successful in life and all of that stuff. But I think it's up to a point. Like it's good if you're competitive and it's healthy and it helps you in a way to actually continue improving your skills. But it's not healthy if you're using the competition as a way to assess your abilities or a way to assess the quality of your work. Kaggle is how do I say it? It's a very closed off space. So I always talk about how Kaggle is very good when you want to learn about machine learning optimization. If you want to learn how to do Bayesian optimization of your hyperparameters, if you want to figure out what are some unique ways to do feature engineering, what are some ways to do feature selection or different things like that, the people who are on Kaggle are probably at the cutting edge of how to do a lot of that stuff. Sometimes we find that a lot of those methods, they might be more complex than you can actually use in the real work when you're working on projects. But I think if you want to learn advanced machine learning and you want to be very good at doing predictive modeling within the space where you assume that all your data is there, your data set is not going to change, the environment that you're going to deploy your solution is not going to change, and all of these things, but you just want to focus on this small area of, I want to make my prediction as good as possible, then Kaggle is very good for that. And I still think Kaggle is very good for that. Especially if you want to learn how to do that across different platforms. So say you want to use one deep learning framework, but you also want to use scikit-learn, but you also want to learn how to do it in R. I think in Kaggle there's a lot of there's a lot of knowledge and a lot of old code there that you can learn from. I think it's a great place to learn. But on the flip side, I would say I think we've seen some weird things going on within the kernels also. I think kernels is pretty good in terms of there's a lot of data exploration and different things like that. There's a lot of data out there in Kaggle as well. So it's definitely a great place to go and look for data that you want to use in your projects. Definitely, I think it's a really good place for that. But I think in terms of the actual Kaggle competitions, I have mixed feelings about them. And I think it's not just mixed feelings because I didn't do very well in them earlier, but I think it's more just, so my mentors, when I first asked them, I told them, so one of my main mentor, actually, he won a Kaggle competition really early, like back in like 2014. And he wrote a paper about it because he was still doing his PhD at the time. So it was like a crazy paper. Like he did all this crazy transformations. Even back in 2014, I thought that was crazy. Even now, I think if I read it again, I'd still think it's crazy. But he was telling me how, these days, if you want to win Kaggle, you have to know how to use cloud computing, because everyone is using cloud computing to train thousands of models, and then they ensemble everything together, and then you end up getting one thing, like one value, which is better than everyone else's. So he told me, Kaggle is very good if you want to learn how to build pipelines. So if you wanted to figure out how you can build an ensemble of different models and get a final score, that's great. You should go out and learn how to do it. Is it used a lot in practice in industry? Not so much. Like, unless you had a lot of budget and a lot of time, maybe you'll be allowed to build 3 models and then you ensemble them together. You won't ever be able to like build hundreds of models and then ensemble them together. But he told me, if you really want to invest your time and win Kaggle, you also need to be very good at cloud computing, and you also need money, because cloud computing is expensive, especially if you're going to be training a lot of models on there also. So I think he was recommending me, don't try and win Kaggle, because chances are you can't, because you can't compete against the people who are spending thousands on GPUs or thousands on cloud GPUs to actually train their hundreds of models. So it's not worth your effort. That was his advice to me. And then he was also saying, I think in the same way, I asked him at the same time, I said, I don't have any advanced degrees. Do I need advanced degrees? I know this is not the topic, but I often get asked, like, do I need a master's or do I need a PhD or anything? Do I need a STEM degree? I always tell people I don't have any of those. I just have a bachelor's in commerce. But my commerce degree, I did actuarial studies, which in some parts of the world is called actuarial science. So technically it might be part of STEM, but I don't know. I think I always enjoyed some of the math, but not a lot of it at the same time. So, but in a nutshell, I think when I asked my mentors, like, okay, should I go get a PhD? Because every other data scientist who's really prominent in the industry has a PhD. And their advice to me was like, they asked me a question back. They said, do you want to do research? I said, I don't know. I've never done research. How do I know if research is for me? And then they told me, okay, pretty much you won't be able to work at the same time. You study, you write papers, and then someone judges your paper, and then maybe you publish. And then maybe you get a job afterwards. So you end up back in the same place. You end up back in industry after you do some research, unless you stay within the research community. So, and then I thought to myself, I've never done research, but I always like solving problems, like real problems, and trying to help people and trying to bring value to whatever I'm working on. Maybe research isn't for me. And then they said, yeah, I think it's a smart conclusion. But then I also asked them, but should I just get the PhD anyway because it looks cool, like Danny Ma PhD, pay me more money or anything like that? And they told me, yeah, you can do it. A lot of people do this. Like, a lot of people have a PhD purely because of the prestige to look really good. And they said, yes, you can definitely do it, but whether it will help you solve more problems, who knows? Like, I think, so in terms of how much impact you want to have and how much value you want to bring by solving problems and doing the data work, it's entirely independent of your education. The only dependent thing is how hard are you willing to work for it. So I know some of the people who I work with, they're like the best machine learning engineer or the best data scientist, and a lot of them don't have degrees. Like they just have a bachelor's degree. Some of them have really big PhDs. Some of them are really great. I think the common thread between everyone is that they work bloody hard. They work really, really hard. They're always trying to advance their skills, trying to improve themselves, not just in data, but just they read very widely. They put themselves out there. They try and help other people with their problems. All of these things are a much better indication of whether you'll be very strong in this field, as opposed to what degree you have. What did you major in? What was your master's degree? Where did you study? All of these things, like they're almost irrelevant. I think you can, a lot of the skills anyway, you can almost learn by yourself or through online courses. Like I was reading something, I don't know whose post it was. I mean, it was something like, during 2020, we realized that universities is same as doing online courses, just you're paying $40,000 a year for them. And I think it's almost bang on. Like, of course, some universities might have a better program than others, but in the end, universities are a very good way to curate a lot of content, a lot of learning content, and you have someone curate everything and build you out a structure and tell you what you should be learning. For a lot of people out there, I'm sure you can do it yourself. Like it might take a little bit longer, and you have to ask a lot of people for their opinions and get a lot of help with it. But I think it's a real plus if you can connect with different members of the community, learn from their experiences, because then you're not just learning something that a professor told you to read from a book. You can do that anyway. Like a lot of my mentors were telling me, oh, if you really want to do a master's, just go on one of their courses, like whatever statistics course, and just get all the reading material, buy the books, read those books, see if you will get more value after reading those books. Because most of the time, I know for myself, when I was at uni, when my professors would give me, oh, these books are for the course, you need to read them, I would never read them. I would just kind of fumble my way through the semester and then cram very hard for the exam and then hopefully get a good score. During university, I was not a very great student. But I think it's quite common for a lot of people. Like university, the main thing that we learned there was how to pass exams. Like we just kind of like learn the right skills, learn the questions that they're going to ask in the exam. And of course we learn a lot of the content also, but how deeply are we learning it? Because when we're not really applying it in real life situations, not very often anyway. So yeah, that's my view. I think I went on a rant.
So like the next question is data science really a very demanding field? Because I feel like, do you believe that it's the hype or the money that people are now focusing into the data science field, or they're generally very interested into research? And because I feel data science as a field is, you need a lot of patience, because training takes a lot of time. When you're training a model, after like 2 days, it will tell you have an error. So a lot of patience and is required. So do you feel that now it's the hype or the money that people are shifting from one field into the data science or something like that?
So I think for this question, in terms of demanding, it might be, we can think of demanding in a few different ways, right? So the first one would be, is it very difficult? Is the field very challenging intellectually, like for your skills when you are working? I would say yes, data science can be very challenging in different areas, but there's a silver lining. Data science is also quite logical, and the way to learn a lot of the skills is very logical. So even though it's very challenging, and let's say when you're starting off in data science, you have no idea what is going on with, say, Bayesian machine learning or all these different terms that you've just heard of or read in a book, and you have no idea what's going on. And that's totally normal. That's expected. The demanding part is, are you willing to put in the work to logically work through all the different logical steps to improve your understanding to the point where you now understand everything and you look back to the beginners and you say, oh, I know exactly what you're feeling. I was there in the same position. Here's what you can do to try and improve your skills to get to where I am. So it is very demanding in that sense, but it's a step-by-step process. So it is demanding, but if you're willing to put in the work and put in the time and effort to learn those skills, it's very rewarding at the same time. So I would say yes, definitely data science is very demanding because of how many skills there are involved and how deep you can go. And it's challenging because learning those skills take time as well. So yeah, there are multiple challenges within there, but it's also very rewarding. When we think of demanding in another sense, in terms of is there a lot of demand for data science in terms of the people who in the industry, is there a lot of demand for people working in the space? Definitely. I think that this demand will only increase over time. So I think I've talked about it before, where it's like when I was going through my career from data analytics going into data science, or even before then, so when I was finishing up my uni, I had an option to whether I wanted to continue working in insurance or different consulting things where they didn't have a data focus. And my thought to myself was, okay, I don't want to work in these traditional industries because I believe that there's only going to be more and more data over time. So I should learn how to use the data properly. So by the time there is a lot of data, I can be an expert in the area, and then I can teach other people how to use the data or use my skills to help other companies use the data, and then I can get more money, for example. That was my thinking back in the time. And I think when you think of the data in that sense, that's definitely the case. Like there's Internet of Things where all these sensors are coming online, which are streaming data like every few milliseconds, or like even faster. That's all getting stored somewhere in the cloud. And of course, the companies who are storing this data, they want to use it. Otherwise, they wouldn't be storing it. So I think being able to interact with different types of data, being able to use streaming data, being able to use all sorts of different things which are coming up is going to be very, very important. I think data science, how it is at the moment, where like literally when you think of data science, what do you think of the skills when people are data scientists? They think, oh, I need to learn sklearn, I need to know pandas, I need NumPy, I need Python, I need all these different tools. I think in the future, a lot of these tools will get automated. Like a lot more energy and effort from data scientists will come from the thinking side. Those are the parts that you can't automate. So back to Vipul's question, it'll be very difficult to code up an algorithm that actually takes into account, oh, was this 6 months of data from a different distribution or not? Of course, you can build if-else rules to manually do that, but I think that's just one scenario. You have to think of all these different scenarios of where it can't be automated, and work on the skills that you need to actually be very successful in that niche area. Then you won't get automated in the future. So I think it's for anyone who's watching and they're thinking of, okay, I need to move into data science as a career. Oh gosh, I need to learn all these tools because everyone else is learning those tools. Yes, it might be a fact now that you need to learn those skills to be compared with every other data scientist who's trying to get a role. But you should also think about, okay, think to the next degree where your thinking has to go, okay, let's say I learn all of these skills. How am I going to stand out from everyone else who knows these skills? Otherwise, someone else who has a better degree than you, who has more experience in Python than you, will get the job. So you have to think about, this is where the marketing of yourself and your skills come into play, where you have to almost time travel to the future and think about, okay, how am I going to be successful in this field? What do I need to do now, and keep working towards to actually get there? Of course, you can take the well-trodden path that other people have done, and they learn the Python, they learn the R, they learn NLP, they learn deep learning, they learn whatever. But these are all just tools, and I think you have to think of it at a deeper level. Like what sort of when you join a team, what sort of team member do you want to be? Do you want to be the dependable person who's very happy to learn different things? Do you want to be the guy who's known for being an expert Python person? So you specialize in Python, for example. And I think having a better understanding of those things is much more important than just blindly learning all of these different tools. So I would say, yes, data science is in demand from the industry, but the data science as we know it will only be in demand for as long as we're not automated away. And sadly, I think it's coming. Like, the automation is coming. A lot of the machine learning pipelines and the model fitting and the hyperparameter tuning and the model training is being automated. But the part that's not being automated is, how do you generate the data sets to feed into the machine learning algorithms? That space is deep, very, very, very deep. And the more you work in the industry, the deeper you realize that area is. I know for me, I really like to spend as much time as possible crafting out my data set and trying to figure out what sort of metrics and how I'm going to use the outputs. But when it comes to model fitting, I will try and automate as much as possible. I'll try and reuse some of the things that I've built before. If there's viable auto machine learning things that I can use on the cloud, I'll use it, because once you've gone through the process of building a few machine learning pipelines, things get boring very quickly. You don't want to be spending all of your time building machine learning pipelines, because you're just doing the same thing over and over again. There's yes, you can add in new different feature selection or different feature engineering tricks into it, but what if you built a system where then you can pass in those feature engineering steps as an input, and then you learn how to build the system instead? I think that's more fun. But yeah, I think there's yep, to answer Mridul's question, it will be, data science is very demanding, as in challenging, and data science is also very in demand in terms of in the industry at the moment, but in the future it might change over time.
So the next question that we have is, as most of the companies do not usually have freshers, can you share any advice for freshers who want to get into data science? Because even I feel I have recently graduated in June 2020, and when you see the job descriptions, they're mostly in like the MNCs. You'll see like 2 years plus experience, 5 year plus experience for a certain role. So how does a fresher get an experience when you're not even providing an experience? Or there are very less universities where these companies come and hire and take few students. So like very privileged colleges, you can say that. But how about the other students? So what is your take on advice on it?
First of all, congratulations on graduating. It's really great achievement. I think I talked about this on my last live also. So I think when you're, as a fresher coming out of university, for example, I actually do not recommend going into a data science role. So it's a bit controversial, but I actually think that you'll get much more success moving into data science as an industry, like as getting into the industry through a data analyst position. And the main reason is because as you come in as a graduate, yes, there are data science roles, but it's very demanding for new data science, especially when you're junior, to start adding value straight away. So for a lot of companies, I know in Australia, it might be different across the world as well, but usually if we're going to hire graduates for data science, we'll just take the university medalists from like the top 2 universities if they want that role. And yeah, for example, there's not a lot of graduates coming into data science. And that's just how it is. And I think that for, I know it doesn't, it's a bit of bad news, but I think it's very common across the different parts of the world. I know in the US, they probably do something similar as well. But when you think of data analysts, there's a much broader range where you can kind of get in. And it's also very good if you can get into a certain industry that has a lot of data. So for example, in Australia, the banks usually take in large cohorts of graduates, and they kind of rotate through different departments of the bank. but they also have a data analytics cohort where they actually get some exposure to the data science teams also. So I think a lot of people, when they're coming out of university and they're very set on moving into data science straight away, they usually don't see the data analytics or marketing analytics or any sort of analytics role as a viable option. I think people should really change their mind about that and try and explore some of these analytics roles, because one of the best ways to actually move into data science is you get given so much responsibility as a data analyst, and you just smash them because they're relatively simple compared to some of the more challenging machine learning tasks that you have to do. And then you get given more and more responsibility. Even though you're a junior, they treat you like a senior analyst. You then talk to your manager and tell them, look, I want to move into data science. Are you happy if I start applying some of the tools that I've been learning in my degree or on the side to solve some of the problems? And because they trust you, because you've been working so hard and delivering really great value as an analyst, they give you the freedom to try and apply some data science. And then so say you do that for 2 or 3 years, for example, in your first role, do you think that would make it easier to move into a data science team where they're doing a lot more of the data science work? Like, it makes sense, right? So I think it's a better progression, and you'll also learn how to use the data, because I think within data science there's almost, I wouldn't say there's only 2 types, but there's sort of different schools of thought. So one would be like, I'm a data scientist, I don't do analytics. Like, you just give me the data, I build the model. What else do you want me to do? That's one group. Another group would be, okay, I need to fully understand what is going on with the data. I need to know where it's coming from. I need to analyze it. I need to make sure that everything is solid before I do any modeling. So it's almost like 2 schools of thought in that sense. When you think of the group that analyzes the data and really inspects it, a lot of them in their past roles were data analysts, because you need to analyze the data. What better place to learn how to analyze data than if you were a data analyst? So maybe I'm a little bit biased, because when I started, I was also a data analyst and I learned how to use data as an analyst. But I think a lot of the times these days, so you think of the data science teams, they might have people who are really good at analyzing the data, and you might also have people who are really good at building models. You might also have people who are really strong engineers. But when you come in as a graduate, which one do you learn from? And that's why I think traditionally when we have data science teams and we're looking for graduates, we'll look for the one who is the most technically proficient. So we usually look within like statistics, mathematics, or computer science, because we know they had to learn such a difficult degree. If we throw them into a difficult situation, they should be able to find their way and learn whatever they need to learn, because they already have a proven track record of doing this. So I think for a lot of companies who are mature in that sense, they're looking for those graduates coming from a really strong computer science background, because a lot of the time when we're working in data science teams, we'll be doing a lot of coding. So the better you are at programming, the more value you can add sooner. So that's why I think software engineering skills are really important, especially for freshers. Like, usually when we think of data science, it's like, oh, I'm used to working in notebooks and Jupyter notebooks and kernels and different things like that. But when you start working in the industry, sometimes you use kernels, but only for exploration. When you do things of really high value, or things that live within an ecosystem and different systems, and you use them in production, we never use Jupyter notebooks. Like, we use them only for exploration. Everything else will be within Python files, within Docker, within all these different pretty much engineering tools. And there's hardly ever focus for that for people who are trying to get into these roles. There's always a focus on, I need to demonstrate how many machine learning algorithms I know, or I need to improve my ROC score. Most of that stuff doesn't really matter when we're working.
So the next question that we have for you is,
oh, yep, I see it.
Yeah.
Thanks from
What
Hanzala.
books? What books you suggest for decision? Okay, sorry, it went.
Yep.
What books do you suggest for? Uh,
Yep. It's okay. I can read
yeah.
it
So
already.
what books? Yeah, suggest for decisions which take in pre-modeling, like how to fill null values, data visualizations, data cleaning.
Yep. I fully understand what this question is, Hanzala. Thank you so much for your question. I think I'm not actually sure if there are many books around this space. A lot of my personal knowledge when I go through some of these things, like how to fill null values and what visualizations to do and the data cleaning steps as part of the pre-modeling checks that you might want to do. A lot of it comes from experience. I'd love to share my experience in terms of like more often than not, you just have to work on different problems and try and understand from the data side, why are there null values? Do they come because of some sort of process? Is it because, let's say, if it's some price value or whatever, maybe it's dodgy because someone forgot to enter the price if they manually enter the data, or if there's some sort of calculation, maybe it doesn't work because the denominator is 0 and it throws you a null value, or all these different things. So the basis of understanding null values is usually to try and look at the systems and try and figure out exactly why they're null. So, and that is more of a business analyst skill. So you can start seeing how like data science is about having such a broad knowledge of like what's going on. So then you can actually make decisions about the data. So I think, yeah, for null values, that's super important. Another thing for how to fill null values is also when you think of, so when you're filling null values, you're fundamentally changing what's going to happen with that record. So a record that was previously not null is now the mean or the median or whatever it is. And to understand how that impacts the prediction downstream is super important. So it would be, let's say, and also the prediction downstream is also dependent on what algorithm you choose. So for example, when we use deep learning, for example, usually we will scale everything so that the mean is 0, and then you would have your z-scores kind of take care of all the outliers, and you get everything is quite standardized within like a scale of -3 to +3. So most of the values will stay around the mean, which is 0, and that impacts the loss of a deep learning model much less than if it was a huge amount of values. So scaling is important. But then when you think of that, it's do you use the median, or do you use the mean, or do you even fill them? Can you just leave them as null? All of these things depend on your knowledge of the algorithm that you're going to use. So I think knowing the chain of how all of these things connect. I wish I could recommend you a book. Currently, I haven't seen anything which is out there. Maybe someone in the comments will comment below and be like, Danny, you're wrong, there's this book. But yeah, there's a lot of these things in terms of null values. Outliers is very big as well. So I think Ayush or Vipul was talking about outliers, where how do you deal with outliers in your data? Do you just remove them, or do you keep them because they're actually valuable information about what has happened for that record? I think all of these things, you have to understand the business and the context of where that data is coming from. And then you also have to understand, okay, if I do a certain action to this data, so say you remove all the outliers, what impact does it have for the algorithm? And I think having more exposure and more time on tools working with different algorithms gives you a better understanding of how this happens. So in a way, I think it would be an awesome book for someone to write. I don't know if I've never written a book. It would be pretty cool. But I think it's, yeah, just talking about null values and outliers. When you think of data visualizations, your outliers will always impact your data visualizations also, because you get like this value that's like all the way out here, and then everything else is stuck around 0. So you have to think of, I think the best way to think of these steps is usually from the logical perspective. If you do this action, how will it impact everything downstream? And then you can, so the science part comes in where you can try different things, and then you try and figure out what happens. And maybe the data visualization, you might want to cut off the outliers at a different point. So maybe instead of cutting off the top 1%, you cut off the top 5%, and then you plot the thing again, and then you see how it looks. I think having that sort of iterative mindset is super important too. But yeah, to answer your question, I don't think there's any books. Maybe I should write one. But I think that when you're dealing with all of these steps in the pre-modeling, the best way to deal with them is to experiment and try different things and see what the impact is. And the more you do it with different algorithms, with different techniques, with different mean filling and null filling and outlier detection and all those sorts of things, the better you will get in terms of the intuition of when to apply something and what impacts will it have. And then when you're working in the industry, you can say, oh, we applied these sorts of transformations. We know that there's little impact on the final prediction, but it saves us a lot of time and gives us better predictions, something like that. So yeah, that was a really great question. Really, really great question.
The next question that we have is, what types of projects should I fill my portfolio with in order to get noticed by recruiters? Image analysis, where should I focus? I feel that it depends on a person's interest. Suppose he is into data analytics, he should write out some good blogs, some good use case studies, and write about it and share it with the community. I think it depends on what is your interest, what is your take on it.
This is a really great question. I think it depends on what role you're looking for. So like Manpreet was saying, if you're going for a data analytics role, you might want to demonstrate a proficiency in SQL, in your data visualization or whatever it is. So here's the thing with recruiters, right? Most of the time, the recruiters are not technical, so they're not practitioners. So usually they'll be enticed by big algorithm names or different things like that. So more often than not, recruiters are usually not the people that you want to be impressing in reality, but in real life, you need to impress the recruiters. So there's a catch-22. What sort of problems should you be trying to solve so recruiters notice you, even though recruiters are just the middlemen to the people, like the hiring managers who you actually need to be impressing. So I think of it in this way. For the portfolio projects, you should think about the main projects which are present in the industries that you want to work in. So, for example, if you're working in marketing, marketing is huge because there's digital marketing, there's traditional marketing. So I usually recommend to my people, try and do a marketing problem because it covers a lot of the people who might want to recruit for data science and analytics. So I generally say, okay, if you want to do a marketing problem, a classification problem is perfect because that's what we do most of the time. We're trying to predict if customers respond to an email, if someone clicks on a button, if changing something led to higher uplift in whatever it is. Most of the time, those are the problems that we'll be solving within data science. I'd argue that over 50% of the problems in data science is specifically focused in that space. Recommendation systems are very popular. Like if you think of Netflix and like Google product recommendations and Amazon and all of those things are really cool. But the thing with recommendation systems is Spotify, for example, like they're very, very difficult to build and they only exist when you have a lot of data. So even if you run through an example of, oh, look, I build a recommendation system using alternating least squares as an algorithm or whatever, like I used a collaborative filter or I used a deep learning solution to do collaborative filtering using an autoencoder, whatever it is, like 9 times out of 10, when you're working in the industry, they may or may not use those methods. And when they do use those methods, the challenge isn't in applying the algorithm. The challenge is in getting the data, being able to transform the data to actually get it to be used for a recommendation system, and then get the outputs of the recommendation system, the algorithm, to be fed back into the system is like 95% of the challenge. I'd say even more. It's like 99% of the challenge. The algorithm is just you're fitting the data. So, and most of the recommendation systems will be using like either supervised or semi-supervised or unsupervised method of machine learning. So most of the time you literally just throw it in and optimize the model, like do some sort of hyperparameter tuning. But that's not the challenge of the recommendation system. The challenge is in getting the data ready and then being able to interpret the results, and interpreting the results with real life recommendations. There's not much data out there for you to actually build a project off it. So I would say if you're looking to do a recommendation system project, try and find one where you don't only have the historic data, where let's say it's like, oh, a customer's going to buy these products or whatever, and you need to recommend them products. I think that's a perfect use case for a recommendation system, but you need to be able to figure out in a smart way, okay, how am I going to split my data so I can demonstrate that I know what I'm doing with the data? Like it's less about the recommendation system as a algorithm perspective, and it's more about recommendation systems as a system. So being able to demonstrate that is super important. I think for image analysis, I know a lot of people really like the image recognition and all those other things. And I think it's really cool. Like, I've always wanted to work in, like, say, medical health, where you use the X-rays to try and predict whether someone has COVID-19, or whether you use something to try and predict whether someone has a certain disease and whether they can do something about it, or personalized healthcare or whatever it is. But those roles that actually use image analysis are really rare in the industry. So if you want to work in those industries, then you should think about doing one of those problems. You shouldn't think of doing one of those problems, like say the MNIST one or whatever it is for image recognition, as the first project that you do. Usually if we see that in a profile, you can tell that this person has not thought through what sort of role that they want, and they haven't done the prerequisite thinking to actually target their profile and their projects to help them get the role. And it doesn't come across too well. Hope that helps.
Yeah, I think definitely it will help. And the next question we have is, for a beginner, what may be the learning path to land up any node in data science, because there are tons of resources available which may mislead. And also I have also read some like posters or like by people learn data science in 20 days from experts and become a data scientist and get hired in Google, Microsoft. So this misleads a lot to a beginner who is going into data science, and they charge you that for 20-day course around 6,000 to 10,000 rupees. So what do you advise on it? How does a beginner stay on it?
Yeah, I think it's a very good question. I think if you see anything where it tries to guarantee you that you'll learn data science within a certain point in time, run away as fast as you can. Most of those courses, just don't do them. It's not worth your time and effort. Like it's not worth your time investment to go into one of those things, but you can always try it if you are very curious about it. But often we see within the industry that there's actually no defined learning path. So like no one's actually gone out and said, you must take course A and course B and read this book and read this and do this and learn this algorithm, because I think any learning path is unique to, like, everyone's learning path and how they got into data science and how they learned something is unique. And I think in the same way, for any beginner, you almost have to, like, I found that the people who have been very successful in this field, they've had to figure a lot of stuff out themselves, or they had to learn a lot of things and learn it the hard way. And that's why they're experts, because they spent so much time trying to figure it out that they had to learn everything like back to front almost. So I think there's always value in trying to learn things the hard way. But I know as a beginner, you're not likely to want to learn things the hard way, because you want it now. You need the degree, or you need the skills now so you can get a job. So I think you have to balance up that need to go really quickly with a longer term view of, okay, if I want to work in data science, surely this is going to be a long-term thing. I should understand that is it realistic to think that I'll land a data science role in 30 days? Today, I've never done programming in my life. Can I still do it? A lot of positive people will say, yes, you can do it. 30 days is nothing. Work as hard as you can. But we have to be realistic here. Like, I think a lot of the skills you could learn, but it's not about how fast you learn them. It's about how much effort you're willing to put in over a sustained amount of time. Because when we're hiring for people within data science, yes, it's very cool if you've learned data science in 30 days, but I'm sure there's lots of gaps, and you may feel either there's two types of people. You do the 30-day course and you're overconfident and you think that you're amazing because you learned data science in 30 days. Or there's the other people who, like, they did the 30-day course and they're super aware that, oh, I just did a 30-day course. I learned a lot there, but I know that I'm not going to stop my learning now. And the second type of people are the sort of people that you want to hire, because when you're working in data science, you're learning all the time. And we want people who can learn quickly. So I think there might not be a defined learning path, but there's a unique learning path that you can find for yourself. I know that there's tons of different courses, paid courses and books and all sorts of things. Like, I think there has to be something which kind of wraps it all together and kind of teaches you enough of the basics, so then you can go and learn yourself. Because I think it's much more powerful if you learn in the way that you want to learn, as opposed to someone teaching you. So I think, yeah, I'll try and link to a video. I've got something where I've got a video before where I have all the different learning, I call them learning paths, but they're just kind of like the different skills you might want to learn for different roles in data science. I think I also split it out between whether you want to be like an analyst or a building type or a consultant type. So I'll try and comment back on that question later with the link. But yeah, I think the most important thing is probably just be aware that there's a lot of resources out there, and it might take a lot of time just to try and figure out exactly what you should be learning, but you should spend time trying to figure out what you should be learning. Because I think if you dive into anything and you let someone else tell you what you should be learning, you're doing yourself a disservice, and you should put in the time to go through that struggle and come out the other end, because I think you'll be much better for it.
Also, I believe you can code data science as read, research, experiment, and be patient. Like, it's
yes,
about
of course.
reading.
Yeah. I think it's, you have to experiment. So say you're going to do some online courses, for example, try and go for the ones with the free trial. So then you can trial it and see if you enjoy the instructor or whoever is doing it. Because the last thing you want to do is pay like $2,000 for a course. There's no returns or whatever it is, and you hate the instructor's voice or whatever it is. Like, I think just try and think of yourself like a startup in data science, where you don't want to make a lot of investment, but you know where you want to go. But you need to run like little experiments to continue validating your ideas, and you keep making more and more larger investments over time until you eventually launch your startup and you become a successful company. So I think it's in the same way you can try and think of yourself as the business, and you're just running experiments to see how you can learn and improve yourself to the best of your ability.
Yeah, like a long-term investment on yourself to get the returns after like some time. I also started my learning while doing projects. Okay, I did a basic, and then while doing projects, when you get stuck or when you debug someone else code, no, you are stuck at some point. So you learn more also while doing these stuff. You take a very good code and start to debug and tweak your own things. Then you get to learn a lot more about that thing.
Definitely.
Okay, we'll be wrapping it soon with last 3 or 4 questions. Being new to the field and not having an opportunity to work as a data analyst, that you told we can not data science but a data analyst. What does a typical work or day week look like? Lot of rambling.
Okay, understood. Thanks for staying up with us, John. I know it's quite late in Australia. Like it's 12:30 or so now at the moment. So I would say a typical, let's go with the data analyst first. So as a data analyst, most of the time we were using SQL. So you try and, let's say you get like a brief from your manager, or if you're working with a marketing team, they might have a few questions that they want to answer with the data. So we try and we go in a meeting. Or first we have some coffee because it's Australia in the morning, you get coffee. Then you go into a meeting, and then they share you these things. You try and ask them a few different questions to figure out, let's say it was about the Woolworths data or whatever. It's like, oh, I want to know which customers are likely to buy Weet-Bix this week because we're running a campaign. I need to know which customer segments to target or something like that. So then I'll be, okay, yep, got this. I go back to my desk. We'll try and run some SQL. So all the data lives within an SQL area. I think we were using Teradata back in the day, so some TSQL. Literally, you just go in there. You might have to run a few queries to try and figure out the data. Depending in which industry, you might have to join a lot of tables or use different databases. Luckily, at the time, we just had one database and everything was there, but in lots of different tables. So we just have to join a few different things together, apply some filters, and then you get the raw data. So that would be like the base table. So when the base table comes out, then you might want to run a few more specific queries to try and do some group by aggregates, or look at the mean of different values, or do a cat or whatever it is to get some more insight from the thing. So once that's all done, we'll try back in Quantium, where we're using Excel for a lot of the data visualization as well. So what we'd do is run the SQL to get whatever data set that we need for visualization, then literally copy and paste that from that SQL area directly into the Excel sheet. The Excel sheet, then we would use Excel to do the data visualization. Once that was done, we would then take that data visualization and pop it into a PowerPoint. And then we would try and build up some sort of presentation to report back to the marketing people. I think this is quite a common process for traditional analytics. So you have a question comes in, you get the data, you do the analysis, you do the insights, you might share it with the team that you're delivering the thing to try and figure if you're on the right point or whatever it is. And then you keep iterating, you update the charts, you get some feedback, and keep going until you go and present it, or you send it off in an email or whatever it is. I think I also worked in campaign analytics, which is slightly different. So we would do all of the above, but then we also have some systems where we'd have to do, like, I don't know if you've worked with Salesforce or different things like that, where you can build marketing campaigns. So we would use those insights to actually go into the system, and then we do a lot of manual clicking and whatever it is to build these campaigns in the systems. So it was a little bit more different, much more attention to detail focused in that sense. But it was more along those lines. So it was not so much there wasn't a lot of statistics being applied. Like maybe once the campaign goes out or whatever it is, we would inspect the results and run like an A/B test to see if the target group did better than the control group or whatever it is, and give you like a significant or not if the p-value was less than 0.05 or whatever it is, whatever you're doing. So sometimes we did that, but it was not very often. Sometimes we would do more reporting. So if the campaign comes back, and then we would do, this happens in analytics as well. So whatever the let's say some sort of marketing event happened or whatever, and the company wants to know what was the impact of the event, we would go in and look at the data before and after, and then see if there was any significant uplift in sales or volume of customers or clicks or whatever it is. So there'll be a lot of that. Sometimes for data analytics projects, there would be more innovative stuff. So you might have to think of, okay, how am I going to visualize the data in a different way so then it makes sense to people, but also shares all the information. So I think when I was working within CBA, I started doing a lot more of the data visualization, but using R and a little bit of Tableau, just to have a bit more complex and interactive data visualizations. So back in CBA, I was doing a lot of interactive data visualization in R. And yeah, that's what more of the data analyst type work looks like. So you start with a lot of SQL, do lots of insights and data munging, and then you would start thinking about visualization and storytelling and presentation. So that's usually where it ends for the data analyst. For the data scientist, what we'd be doing is we would still be doing the SQL. You'd still hit all the databases and whatever. We would also do the visualization and analyze the data to figure out if we were modeling the right thing. One thing as well, for all of these roles, you have to be liaising with different teams to try and understand the data. So you have to understand the business systems and the teams that are going to use the data and going to use your insights to try and figure out what story you should be telling, what problem you should be solving. Same for data science. And I think in data science, once you have those data sets ready, back in the bank, we were challenged to actually, we weren't going to build models unless we had a way to actually use the results. So there would be a lot of consulting work to actually work with different parts of the business to actually get approval for to actually use the model in a marketing campaign or to use the model on the website. So a lot of these things would happen, and we would usually go through those things as more like a consultant type before we did any of the coding. And then once all of those things were approved, we would go in and build the machine learning model, get the outputs, start running experiments. And then we would also do the scientific component of analyzing the experiments, which is also being done as an analyst as well. So you can see where it's like a lot of the roles are similar. The only difference is the data scientist does a lot more machine learning, where they're actually implementing those systems as well.
Now we'll be ending this session with last question to you. If you get a chance to time travel to the back when you have started your data science journey, what would be that one thing you would like to correct about and tell yourself, I think I can do this thing much better and not this?
If I could time travel, I would spend much more time learning software engineering at the beginning. Knowing what I'm doing now, I would also, that's probably the main thing. I would also start using LinkedIn much earlier. I wish I was using LinkedIn earlier and documenting all of the things that I was learning and kind of sharing people my learning journey. So that's probably one of the things that I regret. So if I could actually travel back in time, I would try and capture all of my own learning and try and blog about it or keep very detailed notes about what I was learning. So then I can actually show people my journey from where I was, where I couldn't write SQL, I only used Excel, I didn't know how to Python, or I didn't know how to use R, or all of these things, to where I am now, where I can do all of those things and I'm learning how to do different things also on top of it and teaching other people to do it. So I think it's having that sort of, I wish I did that. So, because that would be really cool.
Thank you so much, audience, for joining me, and of course, Danima, the wizard of data science, on this session. And if you have anything, you can connect with Danima and follow him on LinkedIn, YouTube, and of course, get signed up on his Slack channel. And I hope you like this session. Please like and subscribe to the channel for more amazing content coming up soon. And thank you so much, Denima, for giving us your precious time on the weekend and teaching and educating a lot of us. Thank you so much, everyone.
Thanks, everyone. Thanks so much for having me.